Hello and thanks for checking out this video on the new global illumination that comes with Cinema for the R15. I'm going to show you a few of the new GI methods. Before I do that, I'm going to show you the R14 result and render time. So I have an interior scene here from one of my tutorials, and the final result of the tutorial is this image, and this renders at 5 minutes 22 seconds. So we'll come back to this to compare the quality of the GI. For now, let's go back to R15, of course, and let's go into the render settings. Now, you'll see that the interface has changed. We now have a primary and secondary method. Now, most of these options we already had in the previous GI iteration in R14, but this is a much nicer system. So basically, there are two primary methods that you already know. So that's irradiance cache and the QMC render. That's similar to what we had before. But now instead of all those options, you have a few secondary methods. So there's QMC and irradiance cache again. And then we have the radiosity maps that were also in R14. And we have the new light mapping. So you can mix and match. Not every combination makes a lot of sense, but it's cool to be able to at least try it. And in some scenarios, even the strangest combination might lead to proper results. So that's kind of the interface change we have here. Now, if you want to use if you want to work the way you're used to in R14, so just rendering a full irradiance cache, then you just set both the primary and secondary to irradiance cache. And any diffuse depth above 2 also uses the secondary method, obviously. So there's not a third or fourth option there. And well, the R14 render is set up like this as well. So I have the same settings. I have the same sample accuracy, so medium settings. And I have the irradiance cache record density at low, which is also the same setting as in the other. Well, it's a little bit adjusted, but it's very close. Of course, it's a new method, so it's always a little bit different. So let's render this and see what we end up with. So you'll see that the render process looks different. Instead of those red spots, we're now immediately seeing some really big pixels, basically. We're rendering this at a resolution of basically 8 times the actual pixel size, and then we get the finer steps. So it's very similar to the previous GI in that respect. It just looks a little bit different. And in my opinion, this is quite nice, because especially with scenes that are not this heavy, this is an interior, so it's always going to be very heavy to render. But with faster renders, you get a quicker idea of the illumination. So already here you can pick it up pretty well if you have a little bit of experience with these caches and how they look in their pre-pass. Alright, so this is the last pass it's working on now, and this is already a lot faster than the R14 render, sorry. So almost finished, and if we go back to the R14 render, that took 5 minutes 22, which was most of the time was the GI cache. So if we now go to the R15 render, that's 1 minute 20, and it's already finished. Okay, so now it starts rendering. I'm using the physical renderer here, so this is why you're only seeing 1 or 2 buckets. And let's speed this up. There we go. So 3 minutes 21 seconds. So we saved 2 minutes over the previous R14 render. So that's pretty massive. And let's also have a look at the GI solutions. Now, remember, we use the medium accuracy and a low record density, and we have an interior scene. Now, interiors do need very good GI solutions to really work properly. So this is kind of on the edge. You'll see some smaller artifacts, but it's a nice way to compare the quality of the GI solutions at these levels, because when you just set everything to max, then you'll automatically end up with a proper render, but then it's harder to compare the quality. So let's go back to our 14, and I'm just going to click and switch between them. And first of all, let's have a look at this area, which is a very tricky area because there's a very thin board there. And in the R14 render, we're seeing some artifacts here and also some light leaks. So you're seeing some brighter spots here. If we go to R15, you're also seeing the artifacts. So because we have a similar accuracy, so the amount of artifacts is sort of similar, but the light leaks are not really noticeable anymore, at least not as prominent as in the previous R14 render. Also, let's have a look at this area over here. So this cabinet is very close to the wall, but in the R14 render, you're seeing a clear gap between this. So it doesn't look really connected to the wall. And in the R15 render, it's much better. So again, if you compare this, and that's usually an issue with these kind of cached solutions. They tend to blur your GI solution and you lose those very sharp shadows. Similar for the TV. So in the R15 render, this looks quite nice, this soft shadow. And in the new render, you can clearly see that it's blurred near the edges. So lots of improvements here. When we look at the curtains, you'll see that it looks a little bit different, but both renders look quite all right. So it's usually those smaller problem areas where you can really see the difference. So overall, very good performance. The GI prepass was about 3 times faster, and it just looks a little bit more detailed even. Of course, you can make the quality better if you want by increasing the accuracy and the record density. But I think this works pretty well, and it's a good trade-off between quality and time. So that's your primary irradiance cache. Now let's have a look at some of the other options. So I set up this light mapping render setting, and basically it works like this. You have a primary method. So again here I use the irradiance cache, and then for all other bounces you have a light map. Now the light map sort of just computes all the directions that light scatters, and once the primary irradiance cache hits a spot on the wall, for example, it automatically knows I'm going to go in this and this and this direction, and then I'm going to end up with these results. So it's sort of almost caching the all the directions of the lights. So it's a very efficient way of computing multiple bounces, and especially because it's not really slowing down when you increase the depth. So we have a depth of 16, which is really huge, but that's all right for light mapping. So you can lower this if you want, but it's not going to have a big effect on your render time. The light mapping settings, you just have a path count. So the larger you make the path count, the more samples are used and the more accurate your light mapping solution will be. And you have the sample size, which is obviously the visible size of each light mapping sample. So those are the two main settings. And let me just hit render to show you what happens. And this light mapping is the very first step, even though it's a secondary method, so that might seem a little bit counterintuitive, but it's first computing all those directions of the light. And you can clearly see that this is very fast. The quality is still improving a little bit. It's almost done. So there we go, about 20 seconds. And now the irradiance cache only has to compute one depth, and it's just using the information in the light cache. So it's very efficient to do it that way, especially when you really need those multiple bounces that are important for an interior scene. So this is a lot faster now, the irradiance cache. We're already almost done here. So this is the last step, and let's have a look. So we're a little above 50 seconds, and that's done. So about half a minute faster. And now, of course, let's speed up the render to view the results. Here we go. This is almost finished. And 2 minutes 25. So again, we won about a minute. So we both have a faster GI prepass and then also faster render time, because the light mapping cache is a little bit easier to read. So let's compare the results. Well, because of those higher diffuse depths, you'll see that the sunlight is having a much bigger impact on the lighting because it's able to bounce around more realistically. So we end up with a more yellowish tone. So obviously when you're working on a project, it's good to decide which GI method you're going to use because the results will look a little bit different because of those higher diffuse depth effects. But overall, light mapping is of course more accurate, more believable because it uses those depths that you have in reality with real light. So when we look at the quality of the GI solution, it looks very similar. So if we look at the TV or this sharper shadow here, we didn't lose any of that sharpness, and that's because we have the primary radiance cache. That's still the same, so that's computing all those harder shadows. And then when we look at this problem area over here, you'll see that we have a similar amount of small artifacts because of that medium accuracy. So again, if you boost that up, you'll lose those. But overall, I think the light mapping solution looks a little bit more natural. Here the shadows are quite dark because of the lack of diffuse depth, and here they're very, very subtle, so much more believable and lifelike. And well, similar when you look at the curtains, for example. In the previous version, we had a small light leak over here. That's also gone. This is a nice soft shadow. So overall, if we compare this light mapping method, 2 minutes 25, to the R14 result, it's a lot better, it's a lot faster. So a very, very big improvement for people, especially who need detailed GI solutions. If you have an exterior scene with quite simple GI, the previous version was always already very good, but this will just speed those harder renders up a lot. Right, so that's the basics. I might do a more detailed tutorial on the new GI if there's interest, so please let me know in the comments. I hope you enjoyed this video, and please look forward to R15.